Hello students, today we are going to discuss about Cannizzaro reaction. Cannizzaro reaction, it is present in carbonyl compounds. So Cannizzaro reaction nothing but two aldehydes, which are aldehydes which are lacking of alpha hydrogen atom undergo disproportional reaction, which means reduction, redox reaction, which means or redox. It means oxidation, reduction, both taking place in one reaction. Reaction in the presence of strong base, like NaOH, KOH, etc. and forms what it forms? Alcohol and salt of an acid. Salt of an acid is called as Cannizzaro reaction. See what is Cannizzaro reaction means? Two aldehydes which are lacking of alpha hydrogen. Lacking of alpha hydrogen, nothing but alpha hydrogens are not there. Alpha hydrogen should not be there in the aldehyde compounds. Undergo disproportionation reaction or else redox reaction. See, one is going to taking place oxidation and another aldehyde is going to take place reduction in the presence of alkali KOH or else NaOH and forms one is alcohol, which means reduction is taking place for one aldehyde, and salt of an acid, which means oxidation is taking place for one acid. So if we see the reaction, what is the reaction? So reaction if we see means, as I told you, two aldehydes and which are lacking of, which should not have alpha hydrogen. See, if I'll take this formaldehyde H and H. What is the functional group here? Aldehyde, right? Aldehyde is functional group. So beside of that carbon of aldehyde, there is no alpha carbon, which means beside carbon of functional group is called as alpha carbon, but there is no alpha carbon, right? So there is no alpha hydrogen. The hydrogen are attached to the alpha carbons. Those hydrogens are called as alpha hydrogens. But here there is no alpha carbon. Here there is no alpha carbon, only hydrogens are present. But these are not alpha hydrogens. As I told you, the hydrogens attached to alpha carbon atom, those hydrogens only called as alpha hydrogens. So in this one there is no alpha hydrogens, right? So, and one more aldehyde, one more we have to take, right? One more aldehyde we have to take, HC double bond OH. In the presence of strong base like NaOH, it gives what it gives? CH3OH plus HCOONA. So what is this? What is this? This is an alcohol. one aldehyde changed into alcohol, and this is salt of an acid. An acid. It means this is reduced. This is oxidized. Oxidized. Aldehyde oxidized, and this one is reduced. Correct? This one is reduced and one is oxidized. So now if you go for mechanism, first what we have to take, one aldehyde which is not having alpha hydrogen, HC double bond O H. Then this aldehyde is reacting with, see there is two mechanisms are there. If we go for mechanism 1, actually mechanism 1 is nothing but when we are using low concentration base, when low concentration base is used, some base is used, when low concentration base is used, at that time how will be the mechanism we will see now. See, I have taken here one aldehyde group, then what I have to take, OH minus from base. So it is acting as nucleophile also, right? As we know already, this is partially positive charge and this is partially negative charge. Here in C double bond O, which is acting as electrophile, which has less electrons and which has positive charge, that is acting as electrophile, and which is acting as nucleophile, here O is acting as nucleophile. So here already we have nucleophile which has more electrons. Which one it will attack, which carbon, which electrophile or nucleophile? Already this is nucleophile, it will attack the electrophile carbon atom. So how can I write, means see, it will attack the electrophile atom. When it is attacking the electrophile atom, this bond will cleave, this cleavage of this bond will takes place, this bond will move here. At that time what will get, H C O minus, then H, then OH. Correct? Now this OH got attached to that carbon atom. Now one more carbonyl compound is there, right? I'll write here HC double bond OH. This is step 1 and this is step 2, and step 1 is fast step, because just it is taking nucleophile. Fast step, after taking nucleophile it formed this one. This is reversible reaction, so that's why it can reverse also. Next, so this one also, second step also reversible reaction. Okay, now it has O minus, right? This O minus moves here, there is one hydride shift is taking place. When this O minus is moving here, the carbon will be having 5 bonds, right? It should not be having 5 bonds. Then this hydride will move and attack the carbonyl compound. It will, again this bond will move this side. Then what will get, we will get here, for this one will get, for this one we'll get, what will get, H C O double bond O. Then here we are losing H, right? So we'll get, here we are losing H, right? Then OH. Then next carbonyl compound, what will get here, next aldehyde, H, one H is going to attack here, H. Next O minus, then one more H. Here what took place, hydride shift. H minus got shifted. Hydride shift took place. H minus shift. Hydride ion. Okay, in second step, and this is slow step, which means we know slow steps only rate determining steps. It will determine the rate of the reaction and order of the reaction. Okay, now we have here O minus. This O minus will take the hydrogen from here and this bond will move here. Then what will get? We will get, what will get here? We will get first one as H C double bond O minus. I am writing this O as here, and next here this oxygen got hydrogen, right? So what it will be? H C H H OH. This step is proton transfer, proton exchange, proton transfer. Why? Because proton is hydrogen, right? This hydrogen is shifting here. So that is called proton exchange. This is step 3. Now in this one up to here, that's it. This reaction got finished now. This is, what is this? Salt. Salt, right? Formate ion, right? Formate ion. And this one is methyl alcohol. As I told you. And now in this one, which one is oxidized and which one is reduced? Methyl alcohol got oxidized, reduced, and formate ion got oxidized. This one from the base it will have Na, right? Na plus, it will mix with Na plus, then it will form salt of sodium, sodium sulfur, salt of carboxylic acid. Now this is mechanism, first mechanism. And next if we go for, in this, which one is step 2 is slowest step, right? So if we write the rate determining step, rate is equal to, rate depends on what? Rate depends on two aldehydes, what we have taken here, formaldehydes, two aldehydes HCHO, so two aldehydes, then one base and one base. So total order is this one, right? 2 plus 1, order is equal to 2 plus 1 is equal to 3. So this is third order reaction. So if we are using low concentration base in Cannizzaro reaction, that is an example of third order reaction. Next if we use high concentration base, mechanism 2. Mechanism 2 is high concentrated base. When high concentrated base used, at that time what will happen? High concentrated base used means, at that time what will happen? At that time base is high concentrated, like same like what we have taken there, C double bond O H formaldehyde I have taken same, and base I have taken OH minus. This is also reversible reaction, so we have to keep up to second step, it will be reversible reaction, OH minus, then this OH minus is attacking here for carbonyl group which is acting as electrophile, and it will form what? It will form HCO minus, then H and OH. So we are using high concentrated base, right? In second step what will happen? So this is first step, step 1, and in second step what will happen? Step 2. In base OH minus is there, right? That OH minus will abstract the proton from this alcohol. So it will go as H2O. It will remove as H2O. At that time what will happen? what will form? HCO minus, then H, again here also O minus. Why? Because this proton shift is taking place means O minus will come, right? This bond will move here, O minus will come. Next, so this is formed. So after this, step 3 is again next one more what? Aldehyde is there. That aldehyde has to participate in the reaction. HC double bond OH. Now again this hydride shift will takes place. Step 3. Hydride shift. This is slowest step, right? Slow step. Okay. Now this bond moved here. What it will form? HC double bond O minus. Next plus HCO minus H. So with this reaction will get stop. It means what it formed, what are this, what is this? If I write like, if I can write like this, right? H, this one only I am writing in another structure, like easy way. HC double bond O minus plus CH3O minus. It means in this reaction, this is salt of an alcohol, and this one is salt of acid. So before in mechanism 1 we saw only salt of acid, not salt of alcohol, but in this mechanism we are seeing salt of alcohol at the same time salt of acid. Why? Because of base we used high concentrated base. Now this reaction rate is equal to, what is the rate? Rate is equal to, depends on two aldehydes HCHO and two aldehydes and two bases, because it is strong base, right? Here we are using C, here it is participating, and here also it is participating. So this is two types here, two OH minus OH minus 2. So 2 plus 2 is equal to, order is equal to fourth order reaction, 4. It means fourth order reaction. Cannizzaro reaction, when we used high concentrated base, this is called fourth order reaction. So if you see again, means what is there here, mechanism 1 and mechanism 2. See, in mechanism 1 what we have taken? Low concentrated base. When we are using low concentrated base, we have taken one aldehyde which is not having alpha hydrogen, then that is reacting with the strong base, then this got attacked the carbonyl compound which is acting as electrophile. Next it will form like this, then this O minus will shift here, minus charge will shift here, then this proton hydride shift is taking place here. So what will get? It will attack the next carbonyl compound, next aldehyde which is not having alpha hydrogen. This is slowest step in this reaction, so this is called rate determining step. Because of this slow step only we will get the rate. Next it will form this one and this one. Next in this one what is happening here, this O minus is attacking the, taking the H plus from the carboxylic acid, then it formed proton transfer of taking place here, it formed carboxylate like salt of an acid, we can call it as formation, and alcohol, methyl alcohol, CH3OH, that is called as methyl alcohol. Then what is the rate here? It is depending on the two aldehydes present in the reaction and OH minus also. So 2 plus 1 is equal to 3. This is called third order reaction. Next, when we are using high concentrated base, that means we have taken same aldehyde, we have taken One aldehyde we have taken, then O minus OH minus is attacking, but here before transferring of hydride, here OH minus is taking the H from another OH, carboxylic acid. So when this is taking place means this again O minus will come here. So that time again minus charge will move here and H will again hydrogen transfer will takes place. That is what we'll get the two salts of an acid, salt of an alcohol. Here salt of an acid got oxidized and salt of an alcohol got reduced. This is about mechanisms and reaction. If we see the uh, crossed Cannizzaro reaction. Crossed Cannizzaro nothing but two different types of aldehydes which are not having alpha hydrogen. Crossed Cannizzaro reaction. In crossed Cannizzaro reaction, we have to know some points. What are the points, sir? See, what are the points, sir? Low reactive aldehyde. If we compare the reactivity, low reactive aldehyde forms alcohol, and high reactive high reactive aldehyde forms acid. So which means low reactive aldehyde is getting reduced and low reactive reduction is taking place. Reduced to alcohol and high reactive oxidized to acid. These points we should keep it in mind, then only we can do the problems. Oxidized to acid. Sorry, here I wrote reaction. To here, what is that? Low reactive, and here high reactive. Okay, oxidized to acid. Next, as you know already, aliphatic aldehydes like acetaldehyde, aliphatic aldehydes are more reactive than more reactive than what? Aromatic aldehyde. Correct? Aromatic aldehyde. We take one example. See, HC double bond OH, and this is aliphatic aldehyde. This is more reactive with benzaldehyde. Benzaldehyde, you know, right? This one is benzene C double bond OH. Benzaldehyde. This is aromatic aldehyde. In this, which one is more reactive? Which one is more reactive in these two? In these two, which one is more reactive means aliphatic aldehyde is more reactive. So more reactive, as I told you, more reactive, what it will form? More reactive forms acid. So it forms HCOO minus OH minus we have to take, and low reactive metal, low reactive and high reactive, right? So low reactive aldehyde gives alcohol PH CH2OH. We can write benzene as PH, right? See the structure. This one is benzene. Next CH2OH, benzyl alcohol. This got formed. So Here we are getting to know that aliphatic aldehydes are high reactive and aromatic aldehydes are low reactive. If you see the mechanism for this one, see H C double bond O H. So highly reactive aldehydes only getting attacked with hydroxy group. Here hydroxy group. This base is going to attack only highly reactive aldehydes. Why? Because highly reactive aldehydes only having more electrophile nature. This is more electrophile nature than this low reactive. Why? Because highly reactive aldehyde. So this one moves here same like as we studied in mechanism. So what it will form? HCO minus OH. Now again benzaldehyde is there, right? I am writing benzaldehyde as PHC double bond OH. In place of benzene I am writing PH. You know already, we can write. Next, this O minus comes here, and here one more hydrogen is there, right? This one more hydrogen moves here. Then this bond moves here. So what it will form? It forms HO double bond O, then OH, then what it is forming? Plus PH CO minus and 2H. Here one H is there coming from there, right? H. Next, this oxygen is taking hydrogen, proton shift is taking place, then it forms H C double bond O O minus and PH CH2 OH. These are the products. So what is this? Carboxylate, salt of acid and alcohol, benzyl alcohol. That's what. And if they'll give like the electron withdrawing groups and electron donating groups, you know already electron withdrawing groups means which are having less electrons and it needs electrons, and electron donating groups means which has more electrons and it can donate electrons to other groups. So if they'll give, you know already aldehydes containing electronic withdrawing group. Electron withdrawing group means electron withdrawing groups that will have. Next examples, if you see means examples if you see means electron withdrawing groups. It has, you know, inductive effect and resonance effect, right? Electron withdrawing groups, this will have inductive effects like minus I and minus I R groups, and electron donating groups, donating groups which are having plus I, positive charge, positive inductive effect, and plus R, which means positive resomeric effect, resonance effect. So these are having, in this which one will be more reactive, which aldehydes will be more reactive, which aldehyde having electron withdrawing group or else electron donating groups. Electron withdrawing groups are more donating, more reactive. Why? Because it will increase the electrophilicity of carbonyl compound. Electron withdrawing aldehydes, group aldehydes, more reactive as compared to electron donating, more reactive. So what it forms? More reactive means, you know already, acid it forms. So next one, electron donating groups, donating group aldehydes. Electron donating aldehydes, what it will form? It forms less reactive, it will be less reactive aldehydes, and it forms less reactive means, you know already, alcohol it forms. So if we take one example, we'll get to know. So if we take like Cl and Cl. First example 1. If we take this one, Cl and CH double bond O, which means we can write like this also, C double bond O H, and also we are taking here Me methyl group, Me C double bond O H. In these two, which one is electron donating group? This is electron donating group, right? Electron Me is methyl. Me nothing but methyl. Me is electron donating group. And Cl is electron withdrawing. It is Cl, you know already, Cl is electronegative atom. So it will pull the electrons towards itself. So electron Cl is electron withdrawing group. So withdrawing group we will be having more reactive. So this one is more reactive. This compound is more reactive. And this one is less reactive. So what will be the products? What will be the products? You see the products. What will be the products? Cl, with Cl having aldehyde having Cl will form the acid. An acid. It will form an acid. C double bond O minus. This is an acid, salt of acid. Because Cl is more reactive, because it is having electron withdrawing group, salt of an acid. And this one is plus methyl having aldehyde which is having methyl group. It will form what? It will form? It forms alcohol because it is less reactive. CH2OH. Why it is less reactive means, see here, you know already methyl is donating group. When it is donating the electrons towards itself, then here you know like it is acting as electrophile, right? This carbon is acting as electrophile. So the electrophilicity will decrease. Why? Because it needs electrons. Here methyl itself giving electrons means its electrophilicity will decrease. But here in this chlorine is electron withdrawing. It is pulling electrons from the benzene and from this aldehyde. So it will increase the electrophilicity, positive charge here. So that's why OH can attack easily. That's why it is more reactive. Got it now? Yes. So salt of an acid. If we take another example if we take, another example, what is the example we have to take? See, I will take this one. Second example, CCl3 C double bond OH and plus H C double bond OH. In these two, which one is more reactive? This one is more reactive. Why? Because it has three chlorines. Three chlorines will pull the electrons from the C double bond O. More reactive. So it gives less reactive. So what it forms? It forms CCl3COO minus CCl3 C double bond O minus, salt of an acid, plus here alcohol group. Here I forgot to write alcohol. Next here what it will form? CH3OH, alcohol and acid, salt of an acid. This is all about Cannizzaro reaction. We can see so many examples like this. It depends on the reactivity. You got it now? Yes, you might have got it. See, I am explaining again crossed Cannizzaro example. See, crossed Cannizzaro, before going to crossed Cannizzaro, you should know which aldehyde is less reactive and which aldehyde is more reactive. If you know that, you will get to know. Less reactive aldehyde forms alcohol and high reactive aldehydes forms acid. And low reactive means reduction will take place, and high reactive means oxidation will take place, it forms acid. Now you can see aliphatic aldehydes are more reactive than aromatic aldehydes. So aliphatic aldehyde I have taken simple aldehydes, formaldehyde. If I take means aromatic aldehyde, benzaldehyde I have taken. So which one is more reactive? Aliphatic aldehyde. So formaldehyde is more reactive, that's why it is forming HCO minus. Now one more is there, right? Which is less reactive? Benzaldehyde. Benzaldehyde is forming alcohol group. Okay. Here we can write R. These both are same. In place of benzene I am writing pH. Now if you see the mechanism, as usual same like mechanism 1. Next, electron examples. If you see again affecting more reactive, which is more reactive, which is more less reactive, and electron withdrawing groups like minus, it will follow minus I means inductive effect, and which are withdrawing groups, and minus R. But here electron donating group, sorry to keep here minus I kept, so here we need to keep positive. So plus I and plus R and plus M plus H also here, plus H, because hyperconjugation also might be possible. And electron withdrawing groups, which are electron withdrawing groups aldehydes, that will be more reactive, that will form acids. And electron donating group aldehydes are less reactive, so those will form alcohols. And if you see this one, Cl, the aldehyde attached with Cl, and that aldehyde which is having methyl, which one will be the electron withdrawing group? Cl. You know already Cl is electronegative atom, so it will pull the electrons towards itself. So that is called more reactive. Why? Because here if it is pulling the electrons, will form the, it forms the it will increase the electrophilicity of this carbon. Next, when it is methyl is taking means, when methyl is taking means, it will increase the electrophilicity, it will decrease the electrophilicity, that's why it is less reactive and it is more reactive. Less, you know already, less reactive will form alcohol and more reactive will form acid. Next, more, if we take CCl3 C double bond OH, and next if we take C double bond OH, in that CClO3 C double bond OH is more reactive. Why? Because 3 Cl groups are there. 3 Cl means which one can pull the electrons, because it is electronegative, it will pull the electrons from there, so it forms an acid, and it forms normal formaldehyde is less reactive, that's why it will form alcohol. This is all about Cannizzaro reaction, which is very very important to JEE mains and advanced and NEET, also EAP set. Cannizzaro reaction. Two again I am telling, two aldehydes which are lacking of alpha hydrogens. If alpha hydrogens are there means it will take place aldol reaction. So two aldehydes which are lacking of alpha hydrogens, which are not having alpha hydrogen atoms, undergo disproportionation, which means redox reaction, which means one is oxidizing and another one is reducing in the presence of strong base like NaOH. Here I forgot to write strong base, it is strong base like NaOH, KOH, etc., and forms alcohol and salt of an acid. This is called as Cannizzaro reaction. That is all about Cannizzaro reaction. Thanks for watching and keep support me. I'll upload very important and useful videos for JEE mains and advanced exams and NEET, also NEET exam. Okay, thank you for watching. Subscribe the channel.